Hello, everyone, and welcome to the Everything Else show. I call it that because it's everything else besides what you usually see me on, and it's things that interest me. I was contacted by, I believe, a publicist for Vice that connected me to our guest tonight, Becky Ferreira, and she is going to be talking about the possibilities of life on Europa. I'm excited to have her on, and helping me out co-hosting tonight is Marc D'Antonio, an astronomer and a frequent guest of the show. So, Becky, welcome to the show.
Thank you so much for having me.
Thank you for being here. And here is Marc D'Antonio.
Hello there. Thanks, Martin. Hi, Becky. How are you?
Good. How are you, Mark?
Fine, thanks.
Becky, so how did you get interested in this topic to begin with? I mean, in general, how did you become a science writer? And was it your lifelong search of science, and would that always interest you?
Yeah, sort of. I mean, like probably a lot of people, I watched the original Cosmos with Carl Sagan, and I kind of it started percolating then. I really enjoyed just the presentation of the science in that. And when I went to college, I tried doing a couple scientific fields, but I kind of was like, I can't decide on this. And it was much easier to just be a writer where you can kind of just hop into the scientific worlds of people who are doing often like extremely niche research and then just hop out of it, So I just really enjoyed being able to kind of, just phone up or talk over email with people and share their stories, and meant that I didn't have to decide if I wanted to be an astronomer or a paleontologist or a geophysicist or whatever. You can kind of be everything when you're a science writer.
Oh, I bet. And how do you back up like sources and things like that? I mean, do you have to do a lot of research when you're doing this type of thing? I'm going to pull up your article also here as we are talking.
Well, I find that's one of the nice things about being a science writer. I mean, for this article, for instance, I think I only spoke to the lead author. Often it would, it's fun to, talk to a lot of people in the field, but that can take a lot more time. So, but one of this nice things about this is that it's kind of pre-vetted a lot of the time, right? That this was published in Nature Communications, so it was peer-reviewed, and so a lot of the kind of vetting is done already. If you want to get really deep into a topic, talk to a bunch of sources, that can be really great because you often, I mean, practically always get some lovely debates between the scientists about either nuances or just like the main story. But yeah, mainly I will always talk to the lead, ask what they think. And honestly, like one of the nice things again about being a science writer is that they'll like volunteer the limitations of their study. That's something you don't get with like politics or entertainment or anything like that. So, yeah.
Yeah, that's great. Well, this has always fascinated me. I heard something about the possibility of life on Europa, this particular article that you wrote. And, I mean, just we talked a little bit off air, and just the gravity of Jupiter just causes the moons, what we know as the Galilean moons, or I know they started out as the Medici stars or something like that. Way back, they were first named something like that. But the four moons that we see going around Jupiter and this one appears to be ice covered up to, I believe, was it 15 miles or something like that? Or, I don't know the details. I know it's something like 600 million miles away, and so it's not going to get solar energy from the sun as far as life goes.
Yeah, no, it's a fascinating moon, and you mentioned like it's got interesting history too, observed by Galileo, and is like very much a part of kind of discovering our own solar system. Watching these moons orbit Jupiter was kind of a tip off that we might be orbiting the sun, for instance. And then Voyager took these amazing, the Voyager mission in the 80s took these amazing shots of it. And it's very clearly an ice moon. There's a range of estimates for how thick the shell is, going up to like 100 kilometers. But it's the smoothest body, major body in the solar system. It's looks like it's being replenished by this possible geological cycling with the ocean that's underneath it. And one of the things that I think is great about it, even though it's just the size of the moon, more or less, just a little bit smaller, the estimates, the models for this subsurface ocean it could be 2 to 3 times as much water in there as all the oceans on Earth. So small but mighty, I think, in terms of that. And then, I know Marc knows quite a lot about the tidal flexing issue on that and the kind of interesting sources of energy that could be in there. So definitely would love to hear his thoughts on that as well.
Yeah, go ahead, Marc. This is an image from the I believe it's from the Voyager, which is amazing. Just amazing.
Those long lines you see are like fissures, and when the ice cracks and refreezes, which happens rather quickly because it's of course very cold at the surface, the brown color is actually that stuff welling up from those cracks. And Europa has this particularly interesting feature on it that's called freckles. And there are these brown spots that appear. They look like age spots, okay? But they're actually these brown upwellings from the interior. And that stuff inside Europa is really the most important thing to study. And we have to get a lot closer. We have to actually get that Europa Clipper mission out there. Because we need to get to this moon and figure out what's going on in the interior. We can guess, right? Becky knows this, I'm sure. We can guess what's inside Europa. We can guess at the thickness of the ice mantle. We can guess at the internal temperatures. We kind of have an idea. But everything is a model, and there's no specific data other than what we see visually in the imagery and in some of the upwellings that have made its way into the exosphere, the area around the moon. Okay. The atmosphere on Europa is exceedingly thin. It's just a few particles per million of material that we would like to see, right? I mean, we know that there's water there, and we know that Europa, like Enceladus at Saturn, is spewing some water from time to time. And that's very promising, right? I mean, I think you wrote about that, Becky. I'm not sure, but it's just a moon, I think, that really takes the cake for me. This is the place to go, man.
Mm-hmm.
So Becky, have you thought about what a mission would look like to find life on Europa? I mean, they'd have to drill down. I mean, isn't there a movie about that? I think there's.
Yeah, Europa Report.
Europa Report was a great movie.
It was fun. No, and it's a challenging moon to explore, as you referenced already. The radiation at Jupiter is really intense, so that makes it really hard to have a spacecraft survive there for very long. And there's, and as Marc mentioned, like, basically don't know much about how the surface is. So planning a lander that's going to be going on this terrain, it's a difficult thing to do. So NASA already has a mission, the Europa Clipper, that's supposed to launch, I think, 2025, that will just be doing flybys to kind of, it will be trying to assess habitability, but I think a lot of it is trying to assess how you would actually land on it. And then you mentioned this, of course, huge challenge of actually getting into that subsurface ocean. That's probably, I would say, decades in the future, because you need, I think, a lander to go there first and kind of assess the scene, and then maybe get some kind of heat-driven probe that can get into the ocean. There's definitely like concepts like submarines and things like that that are really fun to look at, but it does pose this immense challenge. But that's one of the things that was exciting about that study that I covered in that article, is that they're speculating that perhaps there is shallow water pools, possibly even just within a mile of the surface of Europa, that would be protected from the radiation of Jupiter, and that could potentially host like little, I don't know, microbes or something like that. Probably not the kind of space whales or anything that you like to see in science fiction, but that's what's so exciting, is that not only would that be something that would kind of, if these sills, these little pools of water existed, that would kind of hint more that it's habitable. It would also just make it way simpler. If, a lander could then go and possibly drill just a little bit down, and maybe they wouldn't find like intact microbes, but maybe like some DNA sequenceable stuff, like some fragments. And that would be obviously like that. It would change everything to be able to discover something like that.
Yeah, I mean, even go ahead.
Oh, sorry. One of the things too, Becky, which I think is important, and you probably know this too, is that when you have an isolated ecosystem like that, they have to set up their own carbon cycles and other cycles that work to sustain themselves. What brings us the reason that I think life could exist on Europa is two reasons. Number one, our hydrothermal vents have these microcosms, okay, of ecosystems that die out as soon as that hot spot migrates away under the plate. The second one is Lake Vostok. Say no more. Where's Lake Vostok? Lake Vostok's Antarctica. And it's over 11,000 feet under the ice of Antarctica, yet it has over 3,500 species of microbial life. And most importantly, that lake, again, which you already know, sorry for repeating what you already know, that lake, and I'll say it to Martin, that lake has its own cycles that it's set up to process carbon and other chemistry that goes on there. And it's all chemosynthetic life like we're looking for. I think that's great.
Okay, so let's explain to the average listener out there what chemocentric life is. I mean, it's on chemicals, not sun-based energy. Is that correct?
Yeah, you know what it is, right, Becky?
Chemical reaction or chemical something.
Yeah, and in particular, the hydrothermal vent systems is kind of interesting as well, because it's a big theory about how life got started on Earth. Obviously, life was not as habitable, or the planet wasn't as habitable 4 billion years ago, years ago. So one possibility is that hydrothermal vents in the ocean could have been a way for life to emerge, and that would be exciting because that would extend the habitable zones in other systems. We're discussing that, like its habitable zones are usually calculated by the sun's energy. But if you have these kinds of systems that are isolated in deep oceans, which we still do on Earth, then, it's really, maybe there's been speculation that rogue planets without a star could potentially have life in their course because of that, or close to their
I agree with that. I agree with that. Yeah, there's a lot of really interesting theories there, and see, the nice thing, this is why I love astronomy, okay? Because there's so many unknowns. All right, and Becky knows she's having a good time writing about it. I'm sorry, Martin. Go ahead.
Yeah,
it's your show.
Yeah. It's you grabbed my attention, Mark, so I lost my train of thought. But let's see. Okay, I know what it was. That is, doesn't all life, though? I mean, isn't it the energy? Say the big. I've heard this, and Mark or Becky, either one of you can comment on this. That they speculate that when the Big Bang or whatever it was that actually happened, that all the energy that ever will be was created then, and energy just changes form. It doesn't go away, or something like that. Am I getting that totally wrong?
That's conservation of energy, and at an Earth-based system, okay, we can apply it to that as well. But you got to remember that when a star is formed out of hydrogen gas, that's the first thing we get, right? It's the most dominant element in the whole universe, right? Well, when that happens, the star makes its own energy, right? So we actually have a lot of other energy sources in the universe. Now, clearly there was some beginning energy that it all started from, right? And it's unclear to me how the very beginning operated versus where we are now. In fact, cosmologists can't give you a proper answer to that either. So that's sort of a question that will have to, for me, has to remain open. I don't know if anybody has any ideas. Go for it. I'm willing to listen.
But okay, and so does life can exist without any initial source of energy from a sun? Is that correct?
Is that Mark? That's chemosynthesis there.
Yeah. That's the chemosynthetic process that
right.
Becky
And the chemosynthetic process had nothing to do with energy from any sun at any given point historically.
Correct. It's life based on a a place where there was no life, okay, fostered the growth of bacteria that ate the hydrogen sulfide minerals that are welling up from these black smokers, these hydrothermal vents, okay, whatever you want to call them. They have a bunch of names, okay, chimneys, sulfide chimneys. And those bacteria fostered more animals that wanted to eat the bacteria, filter feeders like big giant clams the size of your head, okay, and beyond, and tube worms that have this amazing 5-foot length. You ever see a worm 5 feet long? Go to
I've
the
seen
deep
I've seen
ocean.
those tube worms on some documentary. They're bizarre. Yeah.
They are.
Yeah.
So they foster different kinds of life and different types of crustaceans that have been down there. I actually have a black smoker section over in the other end of my office here I got from Woods Hole Oceanographic Institution, because I used to be up there a lot because I've been in the Alvin, but not in it when it was diving. Okay. So I was on the surface with it and got to know the scientists and so forth, did presentations up there. But these concepts are just fundamental, as Becky said, to the formation of life on our planet. I'm with that 100%.
Oh, so Becky, what about Enceladus, Saturn's moon? What is the difference between Europa and Enceladus? I know there's size difference.
Enceladus is very small. But one of the nice differences is that Enceladus would be potentially a lot easier to study, because it does have these plumes that it shoots out into space. And though Europa does have those as well, it would be a lot easier to just send a spacecraft plunging through. In fact, I think the Cassini orbiter already did that. It just wasn't equipped to actually look for life in those plumes. So if there is life inside Enceladus, which has a very similar, makeup in terms of what they think is inside there compared to Europa, it's just on a very, very much smaller scale, then, it could be blowing that life out into space, which would be a really easy way to get it. Don't have to land at all. So there's actually, I'm based in Ithaca, and at Cornell, there's a scientist, Jonathan Lunine, who is working to try to get a mission called Enceladus Life Finder out there. And it's one of my just like favorite kind of mission concepts, because it just seems like it would be one of those things that would be fascinating to check. And, we already have the proof of concept that you can go through those plumes, and why not?
Now, the plumes on Europa are smaller and possibly not from the depth through the ice. Is that what's the difference?
I actually don't know. I've read a little bit of controversy on the plumes, and so Mark, do you want to take that one? Because I think you know a little bit more about them.
I saw the Hubble imagery of the plumes taken with the Hubble Space Telescope looking at Europa, and there was definitely hydrogen and oxygen in these plumes. So that was part of the reason that they were so dead set on thinking that there's probably an ocean underneath the icy crust. But you got to understand, every one of the Galilean satellites, except for Io, right? We have Io, we have Europa, Ganymede, and Callisto. Well, Ganymede and Callisto are also ice moons, and these can also have potential oceans beneath. I just don't think that we've studied those as much as we have Europa. And Ganymede's the biggest moon in the entire solar system.
Yeah, bigger than Mercury, right?
Yeah, it's a huge, huge moon.
There is a really interesting mission, which the acronym is JUICE. I can't remember what it stands for, but it's from the European Space Agency, that is going specifically to see Ganymede. It will do some flybys of Europa too, so it might be able to characterize that. But I think Ganymede is like one of the most underestimated bodies in the solar system for that reason. Because
I agree.
It's the largest moon, and it certainly has the potential for habitability as well. So that will be a really interesting mission. I think that's supposed to arrive sometime this decade, or anyway.
It stands for Jupiter Icy Moons Explorer.
Okay.
I'm not a genius. I looked it up.
Oh! I didn't know if you were joking. He has a sense of humor, so I didn't know if that was a joke or.
It is. It's Jupiter Icy Moons Explorer.
There you go.
So that's pretty cool. And until you mentioned it, Becky, I didn't know that they were doing this. I knew about the Europa Clipper. Mm-hmm. I know that Europa Clipper was actually a 2-phase mission. One's a flyby, and then one deposits a lander. Now, the Juno mission currently at Jupiter, right, going over the south and north poles, right, unprecedented views. Well, they're going to crash it into Jupiter's atmosphere at the conclusion, and you know this, but Martin may not. But it's to actually prevent contamination on Europa should something ever happen and it ends up crashing onto Europa. So you see, we're thinking about this Star Trek non-directive in the Star Trek directive, right? Non-interference. I mean, it's almost like that, but we're actually, art imitates life sometime, right?
I think actually there are plans for the Europa lander, should it ever come to pass, to like self-destruct as well to try to, because I mean it's a huge problem, that planetary protection kind of issue, and it's something that they're doing with Mars right now, because obviously like there's all these really exciting places on Mars that you want to go to, but you don't want to land your craft there that might have Earth life on it, contaminate it, or of course backward contamination, bring Mars life back to Earth, which
No, that's true.
But yeah, so I think that there's been like some loosening of just like the rules on that, because eventually we're going to have to explore those places. And but if for the most part, like it has been kind of this, I think we're kind of dipping our toe in, so to speak, of these environments where there are real planetary protection concerns, because we're, life on Earth, as you mentioned, with Lake Vostok and things like that. Life on Earth is really good at surviving, where we've got some
tenacious
extremophiles, so they're gonna, it's hard to kill them on those spacecraft. And
yeah, that's right. And in addition, right? I mean, we have to really be careful with Europa, because Arthur Clarke warned us away from it. All these worlds are yours except Europa. Attempt no landing there. Use the others together. Use them in peace. Remember that final message from?
What's that from?
2010, was it?
Oh, really? That's so fun.
Yeah. Which I thought was kind of cool. Yeah, you gotta look it up. It's really cool, But see, what I'm getting at though is back then even people recognized there might be life on Europa. Back when when he wrote that. Okay.
This is a quote by him up there. I like this one.
Right.
Yeah, totally.
Two possibilities exist. Either we are alone in the universe or not. Both are equally terrifying.
Yeah, and that's like Seth Shostak saying, if we're how do you say it? If we're alone in the universe, that'd be a miracle. Okay, but there was another corollary to that too, which I can't remember. I use it in my book actually. It's really true. If there is no life, that's a miracle. That's what it was.
Yeah, totally.
Yeah. Here's a question. I'm not aware of this. What are your thoughts? This is Becky or Mark. Opinion on NASA finding life on Titan, or looking for life?
Yeah, NASA finding. There is a mission in the works right now. I think it's called Dragonfly, that they're going to send to Titan. I think Titan. I don't know. It's one of the most exciting worlds in this way, because it is so strange. It's the liquid oceans are made of methane and hydrocarbons and things like that. So if we were to find signs of life on that world, I mean, it would have to be such a different type of like system. It would be so fascinating. I don't even know how you would recognize it, but it is very much like, I believe it has the densest atmosphere of anything except for Earth in any rocky world anyway. And so I think it's really like an exciting mission to go out there. And one of the missions that I love, Cassini-Huygens. Cassini, of course, went on for many years after the Huygens probe landed on Titan. But it's always like kind of forgotten, I feel like, that we did this amazing landing on Titan, and we have these incredible pictures of what a
the whole descent camera.
Yeah, exactly. And it was just, I think it's the only outer solar system landing that we've done yet. So it's a really big Pathfinder. I'm personally a big Neptune fan. I hope we get a Triton lander out there at some point too, speaking of weirdly habitable places. But what are your thoughts, Mark?
My feeling is that, first of all, the Dragonfly lander, the reason they're calling it Dragonfly, I think, is because it has propellers. It's going to fly. And I think I'm right about it. May not be right about that, but we have to see. But that's the is that the Amazing. Titan?
That's pictures of Titan. Yes.
Yeah, on the way down. Yeah, but the thick atmosphere on Titan, it seems like it's also has some weather, but it probably is a pretty stagnant weather system. But these liquid ethane lakes are just, you think, well, nothing can survive at those temperatures, way below zero. I beg to differ. You're not going to find fish, flying around in there, or swimming around, but you're definitely going to find some potential microbes.
Mm-hmm.
And I think that's I think it's a wonderful idea for a mission. I don't know if it'll ever get off the ground, because you know how NASA is with funding. Sometimes the funding's there, and next year it's not.
Yeah.
Is that
Yeah.
one of the lakes, so-called lakes, right there, Mark, in this image?
And if that's an actual photo, that looks like it could be a artist rendering, but maybe it's not. I mean,
okay.
it does look like a rendering, but it would be an ethane lake, yeah, which is a very fancy hydrocarbon.
And then I think there's also theories that Titan itself might also have a liquid water subsurface ocean. So there's like multiple layers of, of potential habitability there.
That's right. That's right.
Oh,
Yeah.
it's a even if it's totally inhospitable, what a cool little world that is just not like anything in the solar system.
I know. And you remember, Becky, remember the when the Huygens probe actually sent back that first photograph and that long strip, and I'm like, oh, wow! And I just couldn't get the scale. And then they told me that they're all pebbles, because this camera was right down low, and you're only looking at little pebbles.
I didn't realize that. So it's like a very, that's so funny. Yeah. No, because I know
exactly big rocks.
Yeah, this very like vertical frame picture. Yeah.
Yeah, I thought they were big rocks, and no, they're pebbles. It's like, oh, I wanted rocks, but that's okay. I thought it was pretty cool. I just like eat it up.
Taking photos on that kind of hazy, like smog world. Like it's yeah, it would be really interesting to see what they do with the next mission. And yeah, I hope it does get up.
Me too.
So
and
we always go ahead.
No, sorry, go ahead.
Yeah, no, we always often we think of, we're looking at planets out there that are in the habitable zones and stuff like that, but there could be moons as well out there in these solar systems that could be habitable. Matter of fact, there's no way to tell whether there could be intelligent life that evolved on a moon. I mean, that sounds bizarre, but it's a planet in a type of way. I mean, it just depends on what happens to happen there. But does it, Mark? Maybe, I don't know if you know this if you know this in particular, but does like any type of planetary body have to have certain things to make it work? You got to think about it's got to have a magnetosphere, right, to keep the radiation out, or it'll kill life as we know it.
Yeah. Yeah. Sure.
Yeah.
I mean, the magnetosphere, the magnetic field around a planet, traps the solar wind. The solar wind then gets trapped in the magnetosphere, spirals around. That's the source of the Van Allen radiation belt here. That's actually just our solar particle trapped magnetosphere. So that's what the Van Allen belts are. And Mars used to have one, but it sort of died away, which means that Mars ended up still exuding a lot of water molecules, which got broken apart. The oxygen went into the surface, where it bonded with iron compounds and rusted Mars, which is why it's red. Okay. And then the hydrogen got lost to space, right? Well, that was a significant amount of that planet's atmosphere, right? So we have to look at what goes into making a planet habitable, and I'm sure Becky knows this as well. And when you look at a planet, it has to be in that habitable zone where we can have liquid water. Why? Because we survived. We are genesis of liquid water. So we say, well, maybe liquid water is a good place to start. And since we know that life originated in the oceans, we figure that if water exists, potentially life exists. The planet makes amino acids. They were delivered, the building blocks of life. They were delivered by meteors and comets and everything throughout history. So over time, our planet built these building blocks of life all by itself and from visitors from afar. And this led to life here, right? And it gives Becky and I lots of things to talk about.
Indeed, it does.
It does.
Yeah, just like the fact that you were mentioning these chemosynthetic organisms earlier. Maybe they don't need the sun, but they certainly need water. Water is the magic ingredient for sure. So, but water does not have to be in the habitable zone necessarily. Liquid water on the surface, maybe, but as we've been talking with Europa, Enceladus, Titan, all these worlds potentially have subsurface water.
Yeah. And again, like when you were talking about with your article, especially when you talked about Enceladus a little earlier, Saturn's moon Dione, is doing a tug of war with Enceladus. So Enceladus is doing this. I actually demonstrated that for One on Earth on I think it was TLC for once in a while. And actually I covered a balloon with this plastery material, and I started squeezing it to show how Enceladus flexes. And then it generated the fissures at the South Pole that you could see the potential stuff coming out of those vents. And so when you have that squishing going on by that constant tugging between Saturn and Dione, I mean, this almost looks oddly satisfying, doesn't it? You can just feel it. You can almost see the kneading process, right, going on, in the moon, and that kept the interior warm. Okay, even more than its nuclear particles that might be in the center, keeping it warm from its original formation, right? So that kneading process is what makes Enceladus a potential target and gave it those hydrothermal vents. So the same type of thing could go on in Europa, and I'm sure that Becky's got an awful lot of writing to do if she hasn't talked about this yet.
No, it's true. There's never any kind of pause in the habitability stuff, because we're talking, of course, about these wonderful, exciting worlds in our own solar system. But scientists are getting obviously a lot better at looking at life in exoplanets and other systems. And so,
oh yeah,
just we're still trying to figure out what's going on in the deep subsurface of our planet. Like, this is just life is definitely very tenacious out there.
Yeah, theoretically, I mean, we only got down to Lake Vostok in the last few years, relatively, compared to the existence of the human race and the planet. It's been like the last snap of a finger that we actually found Lake Vostok.
Yeah.
Didn't really and get there to see all this life, right? Well, I mean, I think, and I like you're a Neptune fan too, by the way.
Yeah.
I like that.
Oh, that's that picture in the background? Yes.
Oh, that's Pangaea. So that's
Pangaea,
planet actually, but just in a different time of our own planet. I always like to think of it as
sort of think of Gondwana land there, Martin. Okay,
Yeah.
So when you're talking about like chemical energy for life, when you say like, okay, everything needs to eat, right? And so the eating in some term would be that chemical reaction or energy. Is that, I mean, it wouldn't be a species that would be eating something, right? Or would it?
It could create an ecosystem, I think, as you were mentioning, Mark, with the tube worms and stuff. Yeah, I mean, you seem to be much more well versed in the actual chemical process that's going on in these hydrothermal vents, but they seem to be metabolizing minerals, right?
Yeah, and the thing to keep in mind is that for anything to survive, it has to generate energy. And to generate energy, it has to consume something. That something may be living, it may not be. Okay, and generally, living things that have DNA consume some type of material to produce sugars and to continue their lives, right? And they ingest oxygen in many cases in order to help further that process, keep it going, generate energy, etc. And like with the DNA process that Becky's referring to, we're talking about carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. CHOMPS. Okay, that's the acronym, and that's really the basis of DNA. You have sulfur in your bones and all. So, I mean, we have these basic elements here that were generated by our planet, right? And so we know that they exist elsewhere. And the huge question for me is, can we find a similar process at Europa? I think that's why Martin invited me to talk with you tonight, Becky, because he knows I'm a big fan of Europa. So yeah.
No, and it's really interesting to hear your insights on that as well. And it's a world that is just like, it's really been so exciting for really hundreds of years, Yeah, so
I agree.
It's way closer to getting there.
That's right. Ever since Galileo saw these moons, that's just started the ball rolling to all these additional discoveries, right? Over time, it just got better and better and better. And, the time will come when we'll have a presence on Europa of some type. Okay. Just like we have the presence on Mars. Incidentally, I just want to say this, and you can repeat this if you want to, Becky. Mars is the only planet in our solar system entirely populated by robots. So I mean, it's true. Yeah. As far as we know.
Yeah. Maybe some tiny Earth microbes as well got on there.
That's right. Well, that's yeah.
I did want to quickly just ask though for both of you, if the, you know, one of the questions I think about alien life that is really I would like to have answered is DNA kind of, if there were, if alien life does exist, does it rely on DNA? Is DNA something that every life form needs? You know, I think it would be so interesting to find something that was different from that.
Totally agree with that, Becky. In fact, that's one of the main questions I proffer up in the book is, you know, we look at our bilateral symmetry, right? And we look at the symmetry of all living things on this planet, whether radial symmetry, like a tulip, pentamerism, like a starfish, 5-sided symmetry, or our bilateral symmetry. Incidentally, starfish are bilaterally symmetric as larvae, just for the record. Then they go into this pentameron state. So that's, you know, so bilateral symmetry is interesting. And you know, I always ask the question, you look at all the life forms, why all the symmetry? Why don't we have pogo stick cows? You know, they only have like one leg, right? Why? Well, I think the answer lies in how DNA replicates. I'm just a thought, okay? It unzips and replicates a complementary strand. At the macro level, that same thing could be responsible for how the human organism interacts. We interact through bilateral symmetry with our environment. And I think that there's something to be said there. We only have one heart, but it has its own symmetries, right? We have one spleen, but it has its own symmetries. And we have one liver, but it has its own symmetries. And but you know, at the outside, we're bilaterally symmetric. You know, right down the middle, you can say, you know, you do a mirror image and you'll probably look nearly the same, you know. Except if you look like this, like when I do stuff, I want to look very different when you look in the mirror, right? But the point being that bilateral symmetric design is something that I think, because it's prevalent on all life forms and because DNA is present in all life forms on the planet, okay, I think that that's a template that's the universe creates. It's some sort of a template. And it comes from the basic hydrocarbon amino acids and the building blocks of life that are delivered in a way that those are utilized.
That's fascinating. Yeah, I like that.
That's my thought anyway. I mean, I think that it's along the right track, but you know what? We need more research to show.
Sure.
Yeah. And isn't there also a thought out there that there could be possible life that's silicon based?
Okay. Remember the periodic table that everybody hates in high school? Okay. All right. You have carbon.
Oh, I love that table.
So me too. It's like my favorite. I used to sing that table, by the way. There's hydrogen and helium and lithium. I can do it. I'm not going to do it. I promise. Okay. But when we go to carbon, okay, and we look at the carbon atom, you have to keep in mind that carbon atom, number 6, all right, is right above silicon. And the columns represent the most likely elements that are familial to each other, right? So underneath carbon is silicon, right? Next row down, but that row, that column, I mean, means more than the row in this particular case. So silicon is the next likely element that could do what carbon does. Carbon is the granddaddy of all elements. It bonds with more things than anything else in the periodic table. And more importantly, it can break those bonds relatively easily. And those bonds can be changed. Look at that. Look what he's got there. Okay. Yes, you're right. And the thing about carbon is because it has those 4 electrons in the outer shell there that can link with 4 other things, it immediately gives us the ability to link with hundreds of thousands of other compounds, make up hundreds of thousands of other compounds, the things that are required by life. Now, silicon, on the other hand, it has more electrons. You say, ooh, wow, silicon might be good, except silicon is tenacious and it makes bonds that tend to go into crystals. And crystals are harder to break apart. And so silicon being so tenacious is not so likely. In fact, I think it is highly unlikely, you know. But interesting little bit of trivia for you is when you walk on a beach, Martin, you're walking on mostly gas. Silicon dioxide, silicon and 2 oxygens. So the majority of the atoms in a grain of sand are oxygen, not by mass, but just by count. So I think that's kind of an interesting little bit of trivia.
And as far as now, this may be a real layperson's question, but that's what I am. And that is, as far as you know, does life need oxygen that we know of? need to get oxygen somehow?
I mean, with water being kind of the magic ingredient, yeah, I like oxygen being part of that, as far as we know.
Oh, as far as the oxygen in the water, H2O.
Right. Yeah. Metabolizing that.
Mm-hmm.
But yeah, what are the
extracting it? Yes.
what are the chemical advantages of oxygen, Mark, for life there?
Well, I mean, too much oxygen is an issue, of course, and one of the problems with Europa. Let's go back to Europa for a second. If you have too much oxygen in the waters of Europa, then that could cause some other problems. Now, there's sort of a mythos about the fact that if you have too much oxygen, then the water might be too acidic. Well, there is really no direct link between oxygen and acidity in the water, but there is a link between carbonate and bicarbonate ions. Okay, carbon dioxide is more of a measure of that pH than the ocean than the oxygen would be. But if you have a lot of oxygen, maybe you might have a lot of carbon dioxide dissolved in the water, and that could make it more acidic. Okay, you know how it is when there's an old experiment you did in high school. You blew into a straw into water, and the water changed color because you had something in the water to change the color, and you said, "Oh, look, it made carbonic acid." Right? Well, that whole process is something we have to be careful about, and that pH is a measure of acidity. Too much acidity is not good for life, as we know it. But there are extremophiles that love acidic water. So, we can get proven wrong, but you got to look at the flexibility of the niche to support many other types of life forms. And if it's an acidic niche, then that's going to be somewhat limited. You might get life, but it's going to be somewhat limited. So we have to be careful about too much oxygen, which could result in possibly too much carbon dioxide. But oxygen makes fuel for carbon-based, beings like ourselves, right? We need oxygen to start doing this metabolizing in our systems.
Here's a question that came in chat, and it is it possible that Europa could have intelligent life as smart as dolphins or whales or octopus? As far as we know, those type of beings need to they need to like eat other beings to survive, right? It's the fish, the big fish eats the little fish, and et cetera, et cetera.
I think that would be interesting to hear what you have to say about that, Becky. I got my own ideas.
I was gonna say also I think they're all sunlight dependent to some degree, but yeah, I see no reason why not. Frankly, I mean, I think I'm a little. I always want to represent the microbes. I think that they're underrated because, of course,
underrated.
we're macro animals, and this question. Those are three very charismatic animals, right? That we really relate to, that we know are intelligent, that we can have relationships, we can actually communicate with them to some degree. So I think it's always really exciting to bring up those examples. But I just planet Earth, despite the fact that it has complex life on it, and we think that we're the big guys here, it's still a bacterial planet. It's a microbial planet still. They were here long before us. They will be here long after us. They take up most of the biomass. It's still their planet. So I
right about that.
No reason if there's life, if it is a habitable ocean, why not have larger intelligent beings? But also microbes would be great. That's all.
Yeah, and I will say I like that answer very much. That says it all. So I almost don't have to say it, but I think that the octopus. I did a whole radio show. We have a radio show on KGRA called Sky Tour Radio. It's an astronomy show on Sundays, right? And we go from 6 to 8 p.m. And we did a whole show on the octopus. And you say, well, how does that relate to astronomy? Oh, it really does, because we look at how life evolved on the planet, right? And it tells us a great deal by looking at the octopus. The octopus, I think, is the smartest animal in the ocean. I do. It's got it registers feelings. It has the ability to reason, and it has the ability to move itself out of a dangerous situation because it wants to, not because it has to. It demonstrates choice making, which is something that is different most animals in the ocean react to stimuli that say, oh, too hot, too cold, oh, danger, move out of the way. The octopus is inquisitive and curious. What's in there? What's in there? And how can I get out of this maze? And the octopus can also observe and retain what it saw. I don't know if you heard that study or saw the study. There were 2 cages underwater. One was just a clear, open cage. The other one had access to a set of tubes, which went out. And there was a maze that went out to dead ends all over the place. Okay. And finally, there was one path, one and only path that led to the outside back to the aquarium. And one octopus was put in this first side on the left side over here. And the other one was put in the other side and did all the probing to find the way out. And when it found the way out, they took the other octopus, put it in, and it went all the way out the first time. It watched and remembered what the first one did.
Wow.
Isn't that something?
We can't do that.
Yeah.
We can't do that.
The cuttlefish are pretty. The cuttlefish, are you familiar with those? Those are really smart too.
Yes.
Very smart.
And they're very old. Not, particularly each one, but they're very old evolutionarily on the planet.
Yeah.
Right? The chambered nautilus.
Those examples are also great, Martin, too, because, speaking of dolphins, whales, and apes, of course, they're all mammals like us. They're on our branch of the tree. And I think octopuses are so exciting, and cuttlefish and things like that, to have a truly an intelligence that is not really closely related at all to us. And,
right. Yeah. Good point.
And another thing, too, about dolphins in particular, dolphins, like elephants, have a place that they go to die. Very interesting. I actually have up there on my shelf, I actually have a dolphin skeleton that came from Cape Verde Islands. And it was given to me by another science writer, actually, from Woods Hole Oceanographic Institution. And this dolphin skeleton was collected on a beach full of tens of thousands of dolphin skeletons. And this wasn't from a mass beaching. It's from the location where they all seem to come. Many of them come to die and live their last days.
Like an elephant graveyard.
Like an elephant graveyard, that's a dolphin graveyard. Really fascinating.
Incredible. Yeah.
Well, let's talk about life, the possibility of life in our solar system, since that's what we're talking about. The places, I believe it was Venus. They thought there was a possibility that there could have been some type of life in the upper atmosphere. I've always wondered if they'll ever find, fossilized microbes, say, on Mars. It seems like with all the rovers and things that they have there, that they should be looking into that more than it seems that they do. I mean, anyway, I'm kind of throwing a couple of different topics out there.
Well, Becky, what have you done with Venus or Mars? Have you done anything with them?
I love Venus, and there's actually a couple missions now finally going there. Venus is in style again. This is, very exciting. I think there was just a study that came out that was kind of that refuted a lot of the idea of the microbes in the atmosphere, which is sad, of course, but that's science for you. But right. I think the Venusian atmosphere is really interesting. It's very, obviously you think of Venus, you think, oh God, hellscape, nightmare. Don't want to, nothing could live there. But the atmosphere is this much more mild place and could be really interesting to explore more. And then you mentioned, the rovers on Mars. Perseverance landed last year. Its mission is to pick up these samples from this ancient lake bed and to put them aside so that another mission can come and send them back to Earth, which would be the first time we'd ever had pristine samples from Mars. And I think it would be really fascinating if they found fossils there. I mean, there's this whole question of just finding life and then knowing that it went extinct 4 billion years ago, which is kind of a bittersweet thing. But there's also one of my favorite kind of pet speculations, this idea of panspermia, that you could have microbes traveling from planet to planet on meteorites. And I love this kind of idea that maybe Mars and Venus were both habitable back in the day, in the early days of the solar system, and potentially Earth life comes from one of those, and that we're just all descended from Martians or Venusians or whatever, right? Very, very, it's wild speculation, but it's a possibility. We do exchange meteorites from these planets, so yeah.
Well, have you heard one of the latest findings? Actually, maybe you have, Becky, is that much of the debris disk left over from formation in our solar system. Much of these small particles of dust were actually created from big impacts on Mars. And
I didn't know
yeah,
that.
and many of these, that's the theory. And one of these, I forget who did the study, but of these impacts, right, they're going to blow off lots of stuff, potentially organic molecules into space, where they're going to get flash frozen, if not destroyed, and then make their way to Earth. And perhaps the whole concept of panspermia did occur, courtesy of Mars. And then Mars, right? And then Mars lost its magnetic field. Mars died. The lakes dried up because the water went away. The pressure dropped down to 6 pascals, which is a really tiny, pressure. Okay. And next thing you know, we live. So it's kind of interesting. It's almost like the Martian population knew they were going to die, so they left Mars and came here, but they're only microbes when they did it.
Yeah. I love that.
It's cool. I see a science fiction story.
Yeah, definitely. Yeah.
So, Becky, this is your opinion. What do you think it would be like if all of a sudden we could say, hey, we have found life elsewhere? What do you think would change in society, or do you think nothing would change?
Oh, it's so fun, Martin, to get this question because I ask it to a lot of people. So it's kind of like one I've always wanted to be asked. But no, I mean, I think it would be enormous. And I even if it is just microbes, right? And let's assume that it is, because I think I'm much more skeptical about intelligent life being it's just much more rare. But microbes, I mean, it would mean that another sample set. We could answer that question that we were talking about earlier. Does all life require DNA? Just the nature of it would allow us to know where to look for it in other places. But I think, imagine finding fossils on Mars. That's just like, a planet next door, and we're already finding life there. That really kind of implies that it's very common. So I think it would just be amazing for that perspective of just, it's a natural process like anything else that we see in the world. And society, I think, would have a whole bunch of different reactions to that, because we all know we're living in a pretty fractured world. But overall, I think it would just be kind of one of awe and wonder, don't you? I mean, finally, after this millennia long kind of search, to know that we're not alone.
Yeah, I to add, not to throw some fuel on the fire here, but the Chinese just announced in the last couple of days. You know this, what I'm talking about, right?
Yeah.
Yeah. I don't want to steal your thunder on that if you were going to talk about it. Oh, okay. They just announced that they thought that maybe they found an extraterrestrial signal that was of intelligent origin. Okay. Now, they then rescinded that. Now, let me tell you how that could have happened. It could have been that somebody listening to, say, some type of strange fast radio burst, which we've talked about before, Martin, could have said, wow, this looks like life to me. And they put it out. And then finally, when the Chinese national media said, wait a minute, you can't say that. Is this really life? And then other scientists came along and said it might have been a fast radio burst. And so they would have pulled it back. But the outward view is that they announced that life was present, and then the story got quashed. So that leads to all these, right? The whole conspiracy world's going to be up in arms for the next several weeks until it leaves the news cycle. But it is an interesting concept, isn't it? And that's what's going to happen eventually when we find life or intelligent signals. It's probably going to be from one of these radio telescopes that's paying attention to, something out there that's doing something really exotic.
What about the James Webb? Do you think that could actually capture something that would tell us more?
Yeah, definitely. I think again, and I just wanted to add one thing I think is important is that candidates for extraterrestrial intelligence are very common, and it's almost always human interference.
That's right.
The radio signal from us bounced into the telescope. Yeah. So I think that they kind of thought oh crap, everyone's paying attention to this, and this could just be someone's cell phone. But
exactly what she says.
Yeah, with James Webb, I just think it's so exciting because there's definitely, again, the technosignature side of it. But what it's going to be really good at is looking at atmospheres of exoplanets. It's right. Infrared telescope. It can refine in great detail the kind of chemical compositions of these planets. So I think this is one of the kind of, again, bittersweet things about the modern search for extraterrestrial life, is that I think the most likely way we'll find it is like, okay, we have ozone and methane in an atmosphere. It looks like life. Don't know. It's 300 light years away, but that's like our moment of discovery. So it's going to be this kind of thing where it's just looking like at how common these habitable worlds are. And it might not be this kind of very smoking gun kind of evidence, but I think just the fact that James Webb will be able to tell us how common the ingredients for life in an atmosphere are is going to be really revelatory.
Yeah. What type of things will it be able to detect as far as an atmosphere? Like if we were looked at, we have, pollution and, all different things that would show that there's actually life here.
As long as it shows in the infrared, it'll see it. Okay. It can't detect oxygen, by the way. It's not going to see oxygen, not directly. But when oxygen atoms collide with each other, they create byproducts. Those byproducts have a signal in the infrared. So the relative abundances of these collision products will show how much oxygen might be in an atmosphere. So just so you know about the James Webb. So I think that process is something that's going to be exploited to the nth degree with these exoplanet studies.
And it's not the only one. That's what's exciting about this time, is that obviously it's an amazing telescope, but you have like so many amazing telescopes that are about to come online. You've got, obviously FAST is really interesting, and I think it's a great intelligence hunter. And then you have like the Square Kilometer Array that's going to be coming on in the next decade, just the biggest radio array on Earth, and the Nancy Broman telescope and the Extremely Large Telescope in Chile. Like it's just a heyday right now. So lots of answers, maybe not definitive ones, but certainly.
No, but that's all good though, Becky. You're right on the mark with that, I'll tell you.
Well, this has been wonderful. I've really enjoyed this conversation a lot. And Becky, are you reachable? Do you like people to reach out to you?
Yeah, sure. I'm on Twitter, Becky Ferreira, and have my email up there, just Becky Ferreira Advice. So always interested to hear what people think.
Oh, let's see. We have one more question up here. Let's see. How does Europa have so much water and other moons of Jupiter have so much less water? And is it the way the moon developed or something? Any ideas on that, Mark?
Oh,
why one moon? Me? Yeah.
Oh, okay. Well, I was waiting for Becky. I thought she was going to answer it, but that's okay.
No, it's a good question.
Okay. Well, Europa is 2,000 miles across, just under. So, relatively speaking, the amount of water that's there is probably less than what's on Ganymede. Okay. I mean, we have to look at the internal structure of Ganymede and Callisto to know. And it's not the only one. Keep in mind that the entire Kuiper belt, way, way out, and the Oort cloud beyond that, are made of all icy bodies, full of a lot of different types of ices, including H2O. You'll have carbon dioxide ices, you'll have methanol, you'll have all kinds of formaldehyde and stuff, but you're not going to find a dearth or a lack of this water ice anywhere. Water is very common. Hydrogen is very common. Hydrogen is the most abundant element in the entire universe. Oxygen is the third most abundant element in the universe. Next is carbon. So the top four are hydrogen, helium, oxygen, and carbon. So it stands to reason that we're going to get many, many different types of compounds made of those, in my view. And water is one of them.
Interesting. Well, again, thank you both so much. It's been my pleasure to talk to both of you.
It was nice to meet you, Becky. It's so nice good talking to you.
And thank you so much for convening us, Martin. This is fantastic.
Well, great. I hope you have some wonderful stories to write about in the future, including that we have discovered life somewhere. That'll be great to be able to read that.
Becky, maybe we can collaborate on some things. Don't tell Martin. Don't tell him.
All right. Okay. Take care. All right. Thank you. Thank you, everyone.
Bye,
See you next time.